Today, we will walk through CRISPE, a structured way to write prompts that behave like specifications. The goal is not to find magic words, but to consistently produce outputs that are usable, auditable, and aligned to your constraints. A helpful analogy is a requirements document. If you hand a team a vague request like build something modern, you get a lot of interpretation and rework. CRISPE provides the model with a requirement-style brief, ensuring predictable, repeatable output. As we go, each slide introduces one CRISPE component and shows how to apply it with a quick example. We will focus on practical outcomes, how to turn vague requests into prompts that produce usable deliverables, and how to improve reliability through iteration and evaluation. Keep the running example in mind. Analyze churn is a classic vague ask. With CRISPE, we specify audience, data, guardrails, structure, and acceptance checks so the result can support a decision without significant rework. Throughout, you will see one analogy or example per slide, so the framework is easy to remember and apply immediately. A prompt framework is most valuable when the cost of being wrong or inconsistent is high. Without a structured approach, language models tend to fill gaps with reasonable defaults that can be generic, conflicting, or incorrect relative to the task requirements. A framework reduces variability by making the requirements explicit and repeatable. Language models can also produce statements that sound plausible but are not true, which is often referred to as hallucination. This risk increases when the prompt lacks grounding context, when the model is forced to infer missing details, or when the topic depends on time-sensitive information that may not be reliably represented in the model's training data. The intern analogy makes this intuitive. A capable intern can produce polished professional work, but a vague brief still leads to the wrong deliverable because the intern has to guess what matters. The fix is not adding more adjectives or asking for better output. The fix provides a more precise specification that defines the objective, constraints, and success criteria so the work is correct and usable on the first pass. CRISPE is easiest to remember as 6 building blocks. Each block removes a different failure mode: missing context, wrong perspective, vague tasks, messy structure, mismatched packaging, and lack of quality checks. A simple analogy is a restaurant order. If you only say, "Bring me food," you will get something, but you cannot be surprised if it is not what you wanted. CRISPE is the difference between food and a vegetarian entree, no nuts, served in 15 minutes, under 800 calories. As we move through the following slides, we will go one block at a time and show how to use it in real prompts. Context is the place where the prompt explicitly pins the objective, the audience, the constraints, and the data realities. When these are not specified, the model will still produce an answer, but it will be optimized for plausibility rather than for the task-specific decision needs. Clear context reduces guessing by telling the model what matters and what boundaries it must respect. The mission brief analogy helps explain the function of context. A mission brief clarifies the objective, operating environment, constraints, and rules of engagement before any action is taken. A well-written context section does the same for a prompt by establishing the situation, the constraints, and the criteria that should guide the response. A fast way to strengthen context is to include at least one negative statement. A negative statement is an explicit instruction about what not to assume or what is out of scope, such as, do not assume we can add headcount, do not reference pricing changes, or exclude recommendations that require new vendors. These statements reduce confident but incorrect defaults and keep the output aligned to real-world constraints. Minimum viable context is a practical checklist for including enough context to be useful. The goal is not to write a long prompt for its own sake. The goal is to include the information that actually determines correctness and usability, such as the audience, objective, relevant constraints, and required inputs. The flight plan analogy explains why this works. A flight plan is not novel, but it contains the essential constraints that keep the flight safe and on time, such as the route, altitude, fuel plan, and weather considerations. Minimum viable context serves the same purpose in a prompt by providing the minimum set of constraints and inputs needed for a reliable outcome. In practice, minimum viable context supports an efficient iteration process. The initial prompt includes only the essential context, the output is reviewed for incorrect assumptions, and additional context is added only to correct those specific assumptions. This keeps prompts concise, while still improving accuracy and alignment over successive runs. Role is not role play. Role is a compact way to import standards into the response, including what counts as evidence, which red flags to check, the expected level of depth, and the appropriate tone for the intended audience. The reviewer analogy helps clarify the purpose. A finance reviewer typically cares about ROI, cost drivers, and risk exposure. A security reviewer typically cares about threat models, control effectiveness, and residual risk. Role tells the model which reviewer is effectively in the room, which shifts both the content it prioritizes and the way it frames the recommendation. A practical way to strengthen the role is to add a decision posture. Phrasing such as recommend proceed, pause or redesign, and justify the recommendation pushes the model to take a clear position based on the criteria in the prompt. This reduces generic lists and produces an output closer to an executive-ready decision support artifact. Instructions and inputs are the work order portion of CRISPE. They precisely define what the model must do and what information it may use. When this section is precise, the output is more consistent because the model is not forced to infer the task or invent missing details. The fastest way to improve instructions is to choose a more specific verb. A verb like analyze is often too broad and leaves the model guessing what the expected action is. Verbs such as diagnose the drivers, summarize the findings, extract the top risks, or compare options are more actionable because they imply a concrete deliverable. Inputs require a clear binding rule. If the prompt does not provide relevant data or a definition, the model may fill in gaps by guessing or fabricating details. If the prompt includes the data such as a snippet, table, or set of assumptions and explicitly states use only this information, the output becomes more grounded and less speculative. A practical example is a churn analysis prompt. The inputs can include a cohort retention table, and the instructions can require the model to derive insights only from those numbers. An additional acceptance test, such as avoid causal claims unless the data directly supports them, helps prevent confident but unsupported explanations. Structure is what turns a response into a deliverable. Instead of accepting unstructured prose, structure defines an output contract such as required sections, a table layout, or a JSON schema, so the result is packaged in a way that can be used immediately and reviewed consistently. Steps define the order of work and introduce step guards. A step guard is an explicit stop condition that prevents the model from pushing forward when a safety, validity, or evidence threshold is not met. When a step guard is triggered, the correct behavior is to pause, state what is missing or uncertain, and propose the next steps needed to proceed, rather than forcing a brittle conclusion. The checklist analogy explains why step guards matter. Checklists exist because complex work often fails through omission, not through lack of effort. Step guards function like do not take off checks in aviation. If a required condition is not met, the process stops until it is resolved. A useful supporting concept is chain of evidence. High-quality outputs tie key claims to evidence artifacts and clearly state uncertainty when evidence is incomplete. This reduces the use of confident but unsupported prose and makes the output easier to validate before use. Parameters are a part of CRISPE that make the output immediately usable for its destination. The underlying analysis may be the same, but the deliverable changes depending on where it will be used. The duplicate content might need to become a summary suitable for a chat message, a structured leadership memo, or machine-readable JavaScript object notation for an automation workflow. The packaging analogy explains why parameters matter. The same product can be shipped to different customers, with packaging changing based on the destination. The label, box size, and handling instructions determine whether the shipment arrives in usable condition. Parameters serve the same function for AI output by specifying length, tone, structure, and formatting, ensuring the response fits the channel and audience. Presets are a practical way to scale this. A preset captures a consistent house style, including standard tone, length ranges, formatting rules, and safety or compliance guardrails. When presets are used, teams can reuse the same parameter settings across many prompts without respecifying them each time, improving consistency and reducing prompt maintenance. Examples and evaluation make CRISPE systematic. Examples show the model what good looks like in practice by contrasting acceptable and unacceptable outputs, and evaluation makes quality measurable rather than subjective. This reduces ambiguity and improves consistency, especially when multiple people use the same prompt. The unit test analogy explains the value. Unit tests allow teams to refactor code with confidence because they immediately detect regressions. Similarly, Acceptance tests and a clear rubric allowed teams to revise prompts or change models while still detecting when output quality has degraded. A minimal example and evaluation block can be small but adequate. It can include one good example, one bad example, and 2 to 3 acceptance tests that the output must satisfy, such as a word limit, required sections, and a prohibition on unsupported claims. For higher stakes use cases, evaluation can be strengthened by adding a rubric and maintaining a small golden set of representative test cases that is rerun periodically to ensure quality remains stable over time. CRISPE is designed to support an iteration loop of compose, critique, and correct. The value of this loop is that improvements remain explainable and repeatable because each change is tied to a specific part of the prompt rather than relying on broad trial and error. The debugging analogy illustrates the method. When something is wrong in a system, the practical approach is not to change everything at once. The effective strategy is to isolate the failing component, adjust it, and then retest so the impact of the change is clear. This workflow can be applied as a simple 3-step pattern. First, name the failure mode in plain language, such as too generic, off topic, missing key details, or format drift. Next, map that failure mode to the CRISPE element that controls it. Then change only that element and rerun. For example, generic outputs often indicate that the role definition or the examples are too weak, while formatting drift usually indicates that the output structure or parameters are underspecified. A common mistake is applying too little rigor to high-stakes work or too much rigor to low-stakes work. CRISPE is modular, meaning it can be right-sized to the task's risk. Low-stakes tasks may require only a clear role, focused instruction, and fundamental parameters, while higher-stakes tasks benefit from a more complete structure, stronger constraints, and explicit evaluation. The seatbelt analogy makes the trade-off intuitive. The faster you go and the higher the stakes, the more safety systems you want in place. For critical decisions, use full CRISPE with explicit evaluation criteria and verification steps to reduce errors and make them easier to detect. A practical rule for deciding when to increase rigor is based on where the output will go and how it will be used. If the production will be forwarded to leadership, sent to customers, published externally, or used to make a go or no-go decision, it should be treated as high risk. In those cases, the prompt should include guardrails, acceptance tests, and precise verification requirements before the output is acted upon. This slide is a practical troubleshooting map for CRISPE. When an output fails, treat the failure as a symptom and map it to the CRISPE component most likely responsible. This reduces trial and error by focusing revisions on the part of the prompt that actually controls the outcome. The bugs and fixes analogy helps explain the approach. When a product has a UI layout bug, the fix is usually not to rewrite the entire application. The fix is to adjust a specific layer that controls layout, such as CSS. CRISPE provides a similar prompt control surface where each component governs a different aspect of the output and can be adjusted independently. This mapping is most useful during iteration because it makes revisions deliberate and measurable. If the output is off topic, the issue is usually context and constraints. If it is poorly packaged, the issue is typically the output format. If it is generic or shallow, the problem is often role definition, specificity, or the quality bar. If it is overconfident in uncertain facts, step guards and verification requirements are typically appropriate corrections. This slide shows what a complete CRISPE prompt looks like at a high level. Each line represents a required component, and together these components create a prompt that is clear, constrained, and repeatable. In practice, each line can be expanded into a paragraph when the task is complex, but the overall structure remains consistent. The contract analogy helps explain why this structure works. Contracts reduce ambiguity by explicitly stating terms, responsibilities, and constraints. When a contract is missing a clause, people rely on defaults and assumptions, leading to disagreements and unexpected outcomes. Prompts behave similarly. When a CRISPE element is missing, the model fills the gap by guessing, increasing variability and reducing reliability. Each CRISPE line also maps to a standard failure mode that it is designed to prevent. Role and intent reduce generic or misaligned outputs by setting the expected perspective and objective. Context and constraints reduce irrelevant or unsafe recommendations by defining boundaries and inputs. Output format and quality criteria reduce rework by making the deliverable measurable. Step guards reduce overconfidence by requiring the model to acknowledge uncertainty instead of forcing a conclusion when evidence is insufficient. CRISPE is most valuable when operationalized as a repeatable team practice. Instead of reinventing prompts from scratch each time, teams can build a small library of proven templates for everyday tasks, such as summaries, decision memos, analyses, tables, and checklists. This approach improves consistency, reduces cycle time, and makes quality easier to scale across different users. Prompts can be compared to a code library. Code libraries are valuable because they capture best practices, reduce repeated work, and provide reusable building blocks that are maintained over time. In the same way, a prompt library can be versioned, reviewed, and improved so that the best known prompt for a task is easy to find and easy to reuse. A simple governance pattern helps keep the library reliable as it evolves. Each prompt update should include a short changelog entry explaining what was changed and why. After any update, the team should rerun a small golden set of representative test cases to confirm that the prompt still performs as expected and that the change did not introduce regressions. CRISPE is a practical checklist that presenters and participants can apply across many use cases. The central takeaway is that strong prompts are engineered, not improvised. They define the world the model should operate in, the role it should assume, the task it must complete, the shape of the output, the packaging or format requirements, and the quality bar the response must meet. CRISPE can be compared to an operating system. An operating system provides consistent defaults and guardrails so that many different applications can run reliably. Similarly, CRISPE provides consistent defaults and guardrails that help a wide range of prompt types produce predictable, usable outputs. Verification is essential when the stakes are high. Model output should not be treated as a single source of truth for critical decisions. When appropriate, the prompt should request sources, require the model to flag uncertainty rather than guess, and require external verification of essential claims before the output is used. Here is the source of the information for this presentation.